I know I said try, I didn't say solve, so if you finish this, great. If not, we're working on it together. What ideas do you have to start out with? What ideas do you have to start out with? Shimia.
The log base 5 of P. I mean the log base 5. I messed up. P.
Well, which property are you wanting to use first? The division one, the quotient one. So you're trying to separate numerator and denominator. So that's a good thing to start with. Immediately you see there's a fraction. So we want to separate numerator and denominator. So I have 2 logs of base 5. Right? One of them is going to be numerator. What's the numerator?
P.
P. The other one's going to be the denominator. What's the denominator?
Q squared.
Q squared R cubed. The whole thing, right? And what's the operation between the two?
Subtraction.
Follow? Yeah? Does that make sense, George?
Yes.
Okay. Now, we take a look at what we're taking the log of again. Can we do anything to P?
No.
Can't expand. Can we expand Q squared and R cubed?
Yeah.
Yes. Right? What is the operation between Q squared and R cubed?
Product. I mean
Multiplication.
Yeah, product.
So we're going to use a product property. Now, so what would this equal to?
log base 5 of Q
Log base 5,
of Q squared
Q squared, right? Separate that one.
plus
Plus
log base 5 R cubed of R cubed.
the other one, log base 5 of R cubed, right? Now here's where it could get a little tricky. We keep the log base 5 of P, right? Nothing to do there, right? Yeah?
Yeah.
And we're supposed to subtract this guy. Now this guy equals both of these, right? They're added. But when I say subtract, we're saying subtract this whole thing, so we're subtracting this whole chunk.
How is that?
When you subtract this whole thing, you can either keep the parentheses or distribute that negative sign.
Nah,
So when I distribute this, parentheses disappear, right? And negative sign, negative 1, think of it as negative 1 being multiplied times both of these. So this one's negative, and this one will also become negative.
So keep it negative?
Keep it negative, right? Unless you kept your parentheses. For the example, I'm not going to keep parentheses. Okay? So again,
So if I keep the parentheses, I can keep the addition sign?
yes, if you want to keep it like that, right?
But if I don't,
But if you don't, you're distributing that negative. So this guy's negative, and then this guy is also negative.
Alright, I'm picking up what you're putting down.
Okay? Alright? Questions on that? Okay. So we're saying subtract this entire logarithm, right? And this logarithm equals these two added. So I'm going to say, okay, I'm subtracting this. This is what I'm subtracting, right? So that's the same thing as subtracting each of them individually. When we say subtract each of them individually, then we're saying subtract this guy, and then subtract that guy. Right?
So when you break them down, it's
Now
still
does it
gonna
make
be
more
the same.
sense?
Yeah. When
Okay.
you break them down, it's still gonna be the same.
What do you mean? Break it
You
down.
still got put the change the.
Well, we do the same thing, right? We said P we can leave by itself. Can we expand Q squared?
Yeah.
Yeah. Can we expand R cubed?
Yeah.
Right? So let's do that. What would log base 5 of Q squared be equal to? Using which property? When we have an exponent,
Power.
product, quotient, or power?
First you do that,
Power,
then you do
right?
that.
So we would have, how would we write this?
2 log base 5
2 log base 5
of Q.
of Q. Okay? This one? Same property.
Yeah.
What would we write? 3 log base 5 of R. Okay? Now we subtracted this guy. Does the subtraction sign change here?
No.
No, right? So pretty much nothing really changes. Log base 5 of P, we don't change that. Right? We don't have to distribute this negative sign, there's only one. So minus, sorry, it's really separate. Right? We don't have to distribute this one, it's just to itself right there. Alright? So, Can we expand any more? P, Q, or R? Deontay. Can we expand P? No. Can we expand Q? Can we expand R?
No.
So this is our final answer. From one logarithm, we have 1 minus 2 minus 3. Deontay. Right? From one logarithm, we have 1 minus 2 minus 3 logarithms. So that's how we've expanded it. Okay? Deontay, question.
Okay, so like when you say keep it parentheses, right? At the top for the second.
This one? Yeah?
You ain't careful with that, but you keep it at the bottom too, right?
So if I kept the parentheses here, right?
Doesn't matter if we
Then I would have plus there. If I kept the parentheses for the next part, then I would still have parentheses here, like that. Right? If you wanted to keep the parentheses. Because you're still saying subtract whatever this equals to, and this equals both of these. Right? Yeah, so we're subtracting that. But I like it better without parentheses. So that's why I have these.
Oh no, you do that now.
Okay? Alright. On the margin, guys, can you write this example on the margin? Right? On the margin. Just the margin of the page. Give me 1 second, please. Excuse me, it might be in my recording. Thank you. On the margin, can you write,
That's this, right?
yeah. Let's go for M for Marcos. Let's take the 7th root. Oh, wait, sorry. The log base 21 of the 7th root of M. Okay. Here, what is operation on M? What's the operation on M? What are we doing to M?
Square root of 7.
It's the 7th root, right? Now we know that the 7th root is the same as an exponent over here, right? So the square root is the same as a 1/2 exponent. The 3rd root or the cube root is the same as having a 1/3 exponent. The 4th root is the same as a 1/4 exponent. So this would be M raised to 1/7, right? So log base 21 doesn't change of M raised to 1/7. Now we have an exponent. Which property are we going to use? Power property. Marcos was tempted to say quotient because we see a fraction, right? But the fraction is in the exponent, not what you're taking the log of.
So it's going to be 1/7 log
1/7
21
times log base 21
of M.
of M. Can we expand M?
No.
No. It's by itself now, right? Whereas earlier it was raised to 1/7.
This is my favorite number.
I did. Okay. So before we go into condensing, go ahead and expand. Flip the page between 1 and 15. Pick any one or more of the problems.